Welcome, dear student. We are discussing about the physical techniques for synthesis of a nanomaterial. Friends, in this lecture, we have to see what is ion beam deposition. In previous lecture, we discussed about the physical vapor deposition technique. That is a thermal evaporation, then sputtering technique. Then we also discuss about the ball milling method, then pulse laser deposition technique. In pulse laser deposition techniques, the laser beam is incident on the target material, okay, so that the plasma is formed, and this plasma is the deposited on a glass substrate so that we get thin film. Friends, in this lecture we have to see what is ion beam deposition, then the advantages of a ion beam deposition, disadvantages of a ion beam deposition. After attending this lecture, the student will be understand about the ion beam deposition, its advantages and its disadvantages. Ion beam deposition. The ion beam deposition is one of the most commonly used physical vapor deposition technique or method. In this method is discovered by a scientist Takagi and Yamada in 1985. This method is useful to obtain adherent and high quality single crystalline thin film. So, the thin film which is produced by using this technique is that there is a very high adhesion, okay, and high quality single crystalline thin film can be produced by using this method. This is one of the physical vapor deposition technique. The setup consists of source of evaporation. Okay. Here, the ion beam is source of evaporation. Nozzle through which the material can be expand into the chamber. An electron beam to ionize the cluster. That is, source of evaporation means the electron beam which ionize the cluster, or when the electron beam is incident on the target material, then the material get ionized and the formation of a cluster, an arrangement to accelerate the cluster. Okay, so there is some arrangement which accelerate the cluster, ionized cluster. Okay, the substrate on which the nanoparticle film can be deposited. So the setup consists of all these things, and the vacuum chamber, the whole assembly is placed in a vacuum chamber. That is, there is a ion electron beam, okay, which ionize the cluster, okay, source of evaporation, okay, then arrangement to accelerate the cluster, okay, and substrate on which the nanoparticles are deposited in the vacuum chamber. So this is the assembly. Here there is ion source, okay. The ions are incident on the target, okay, so that the it ionize, or the particles or atoms, there is a evaporation, or there is a formation of a cluster. Okay, then this cluster assist by assist or accelerate the cluster by some arrangement. Okay, there is also sputter is there, and this accelerated cluster is deposited on a substrate. Here this is one of the diagram. Okay, both the diagrams are same. Okay, here in this second diagram there is a water is used as a coolant, because when ion is incident on the target, okay, the heat is produced. Okay, so that water is used as a cooling agent. Then there is a crucible in which the target material is placed. When ion beam is incident, or ions or electron beam is incident on the target material which is inside the crucible, okay, the ionized cluster is produced, okay, or electrons is emitted. This accelerated, this electron or cluster is accelerated by ionized cluster accelerating electrode. Okay, then there is a sputter. Okay, then there is a hitter. The cluster, the accelerated cluster is deposited on substrate which is in substrate holder. Okay, the temperature of this substrate or thin film can be measured by thermocouple. The working pressure is about 10 raised to minus 4 to 10 raised to minus 5 torrs. The ion assist gun, here the voltage is about 50 to 200 electron volt. Sputtering gun voltage is about 50 to 2000 electron volt, and sputtering gas is used, that is argon, krypton, xenon. These gas are used as a sputtering gas. Now, on collision with the electron beam, cluster get ionized, and due to applied accelerating voltage, the cluster are directed toward the substrate. Okay, when the electron beam is collides on target material, cluster get ionized, and due to accelerating voltage, the cluster is accelerated and directed toward the substrate. By controlling the accelerating voltage, it is possible to control the energy with which the cluster hit the substrate, so that we can control the accelerating voltage. Okay, accelerating voltage, which control accelerating voltage control the energy. Okay, energy with which the cluster hit the substrate. The stable cluster of some material will be required considerable energy to break their bonds, and would rather prefer to remain as small clusters of particles. Thus, it is possible to obtain the film of nanocrystalline material using ionized cluster beam. So, stable cluster of some material would require considerable energy to break their bonds. However, However, it is not unlikely that some neutral atoms also get incorporated in the film. Besides, the clusters are not mass selected. Therefore, they can have wide distribution of a particle size. In fact, anything that can cross the accelerating voltage can get incorporated in the film. Okay. Now there are some advantages of this deposition technique. First is high energy sputtering coating utilize momentum exchange to make atom and molecules of the solid material to become gas phase, okay, which have very high energy. Then wide application, any material can be coated by ion beam deposition technique. Then good uniformity. The thin film which is produced by using this method is uniform. The particle distributed uniformly over the substrate. The good stability due to the inherent collimations, single energy deposition of ion beam sputtering. The resulting coating is graphically very uniform and very dense and adheres effectively to the substrate. This makes the thin film made by ion beam deposition very stable and durable. So stability is very important. High precision, the energy, size and direction of the ion beam can be precisely controlled and the sputtered atom can directly deposit the films without collision. The ion beam sputtering is very suitable as research method for thin film deposition. So the high precision, that is the thin film produced at a particular accelerating voltage. After some time we prepare same film, then this film may be uniform. Okay, so these are the advantages of this ion beam deposition technique. First is high energy, second wide application, any material can be coated by using this method, then good uniformity, good stability and high precision. Disadvantages of this method. The main disadvantage of ion beam sputtering is that the target area of the bombarded is too small and deposition rate is generally low. In case of pulse laser deposition, rate is very high. But in case of the ion beam deposition, the deposition rate is very small. Here, the ion beam is incident on very small target area and therefore the which produce the clusters of ions of that small area. The ion beam sputtering is also not suitable for deposition as large area film of a uniform thickness. That is, if we consider the large area, then the thin film may be not uniform thickness. The sputtering device is too complicated. The equipment operating cost is very high. Okay, so these are the disadvantages of this method. So in this method we discuss that ion beam deposition is a physical vapor deposition. Ion beam is used to ionize the cluster. Okay, very simple. Ion beam is incident on target material so that we get ionized cluster, and this ionized cluster is accelerated by accelerating voltage. Okay, the cluster is directed toward the substrate and deposited on a substrate. Here you have some assignment. First is explain ion beam deposition in detail. Second, state advantages and disadvantages of ion beam deposition. Third, distinguish between pulse laser deposition and ion beam deposition. Send this assignment on Google Classroom. Okay. In next lecture, we have to see molecular beam epitaxy. Molecular beam epitaxy. This is also one of the physical vapor deposition technique or physical techniques for synthesis of nanomaterial. Thank you.